So chapter 5.1 also talks about quadratic's domain and range. So the general form for the quadratic function is y equals ax squared plus bx plus c. So for domain, the domain of any function is usually restricted by square roots and denominators, because with those functions, if you plug in certain x values, they yield y values that are either imaginary or just don't exist, they're undefined. So, but with y equals ax squared plus bx plus c, there are no square roots or denominators that will restrict the domain. So for quadratics, the domain is always all real numbers, from negative infinity to positive infinity. And this just means that we can plug in absolutely any x value and get some y value that exists and is real. Then the range is going to be determined by the vertex and the ax squared term. So the first example we have is f of x equals x plus 8 squared minus 5. So to find domain and range, the first thing we want to do is find the vertex for this function. And we see that it's already in vertex form. Y equals some a, x minus h squared minus or plus k. And in this case, h is going to be negative 8 and k is going to be negative 5. So we know that the vertex is at negative 8, comma, negative 5. It's given to us in this form. So we know that the domain is going to be all real numbers. Then for the range of this function, we know that a is greater than 0, which means the function has a minimum value. So this vertex is going to be the lowest point of the function, which means then that the range is going to go from negative 5, which is included because it's part of the function, and all the way to infinity. Then our second example, g of x equals negative x squared plus 6x minus 2. So first thing we do is look for the vertex. And this time our function is not in vertex form, so we're going to need to use the x equals negative b over 2a, which is going to give us negative 6 over 2 times negative 1, which just gives us 3. Then if we plug this back in, we look for g of 3, which is going to give us negative 3 squared plus 6 times 3 minus 2. Then we get 7. So the vertex is at 3, 7. And since a is less than 0, it's going to open down. So we have a max point. This 3, 7, the vertex, is going to be the highest point of our parabola for g of x. So as usual, the domain is going to be all real numbers. And then the range, since it opens down, it's going to start at negative infinity, and it's going to go all the way up to the y-coordinate 7, which is included because it's part of the parabola. Then our last example, h of x, is going to be negative 3x squared plus 5x minus 5. This time, since a again is less than 0, we're going to get a max value, which means our range is going to be from negative infinity to whatever the vertex is. So let's look for the vertex. We have x equals negative b over 2a, which is negative 5 over 2 times negative 3. And this is going to give us 5 over 6. Then if we plug this in, back to the function, then our y-coordinate is going to be negative 35 over 12. So for h of x, we have the domain being all real numbers, and then the range goes from negative infinity to negative 35/12, and that's included.